Hello students, welcome back to the class. As in the last class already we discussing about the RC circuit. So in the RC circuit the first part already we solved, that is nothing but the charging of a capacitor through the RC circuit. So as I told in the first video, the RC circuit is a circuit which consists of the resistor and capacitor. Okay, so this is called as capacitor and this is nothing but the resistor. So in a RC circuit the resistor and the capacitor both are connected in series. They are connected in series. Again they are connected to the battery as well as the plug key. Okay, so if it is the case of the RC circuit, then as we know, when we will start the key, means when you will plug the key, then the battery will supply the voltage. So due to that the current starts to flow in a circuit. Current flowing is nothing but it is the flow of the electrons. So as it is a conducting wire, so when current is flowing, as we are talking, no, that is nothing but there is a number of electrons which are flowing in a circuit. So those electrons which are flowing, no, the function of the capacitor is to store that electrical energy. So whatever the energy is there, that electrical energy will be storing by a capacitor. So capacitor will store the electrical energy. At the same time, whatever the resistor is there, it will oppose the flow of the current. So when current is flowing, the resistor whatever is there, it will oppose that flow of the current. So this is the case when you close the key. Okay, so when we will close the key, the current starts to flow in the circuit. So when current is flowing, the capacitor starts its work. So nothing but it starts to store the electrical charges. It will store the electrical charges. At the same time it will oppose the electrical current. So that time we had one equation, that is, suppose the battery supplied the total voltage is equal to E. So E be the voltage supplied by the battery, then this voltage will be distributed among capacitor as well as resistor, isn't it? Because both are connected in series. So whenever the electrical components are connected in series, then what will happen? The total voltage will be distributed among these two components. So what we got the equation? We got the equation E is equal to the capacitor voltage is equal to how much? Yeah, it is Q divided by C, where Q is the amount of charges and C be the capacity of a capacitor. How much capacity it is having to store the electrical charges, plus the voltage across the resistor. So that is given by what? Yeah, it is given by the Ohm's law. So from the Ohm's law, what we can write? So the nothing but I into R. Okay, so E be the voltage supplied by the battery. So when E will be the supplied something voltage, let it be E1, will be flowing across the capacitor, and E2 voltage will be there across the ends of the resistor. So E is equal to E1 plus E2. So E1 value is what? Q divided by C, because this is the capacitor formula. At the same time E2 is equal to what? I into R, because I is the current and R is the resistance of a resistor. So we got this is the equation. So in the last class also I told this is the equation. So now what is happening? So already we plugged the key, so this much is happened. See, here the Q is nothing but what? The number of charges in a capacitor at a time t second. Okay, now as I'll plug the key, this one, so the current starts to flow. Let it be 5 ampere of current you are supplying, means it will not instantly increase to what? 5 ampere. So how it will be growing? Yeah, it will be growing like a 0, 0.1, 0.2, 0.3. So 1 it reaches 1.1, 1.2, 2 it will reach. So like that reaching, it will approaches to what? 5 ampere of current. Means that time the whatever capacitor is there, it will start to store the electrical charges. When time is 0 second, there is no charge. So Q is equal to 0. But in the first case, when you are closing the key, okay, and when time is t, the number of charges in a capacitor is q. Okay, and when time will be maximum, no, the number of charges in a capacitor is equal to how much? q naught. So q naught be the number of charges in a capacitor. So q naught is nothing but what? Maximum number of charges in a what? Capacitor. So now the thing, already it is pressed and it stores the q naught number of charges, maximum number of charges. In the case of studying of discharging, that is charging. So rapidly when it goes on storing the charges, no, that is the charging of a capacitor, we will say, because the amount of current increases, so the storing capacity also goes on increases and increases. So that's when we called it as what? Charging. So now coming to the point of discharging. What is discharging? So discharging is nothing but, say now we close the key, but for a discharging you should open the key. Whatever the key had been closed, no, that we should open. So when you will open, before opening, how many number of charges are in there in the capacitor before opening? So as it is closed, so how many charges will be there? Yeah, so nothing but at time 0 second, the number of charges in the capacitor will be what? q naught. Okay, because already it was pressed. So when it was pressed, there will be a maximum number of charges in a what? Capacitor. And now the thing, when time is 0, already maximum number of charges are there. But when you will release the key, when you will open the key, these whatever the stored charges are there in the capacitor, they will go off. So they will be coming out from a what? Capacitor. Means the number of charges goes on decreases. So when it goes on decreases, suppose at time t second I'll take, as goes on decreases, it will reaches to what? Q value. And at time when it reaches to a maximum value, no, there will be no any charges in a what? Capacitor. Okay, see, before opening the key, before opening the key, at time 0 second, already many number of charges are there. This one we studied in the last class. Okay, and there will be maximum number of charges are there. But how time will be running? You will open the key, so discharging takes place. Discharging nothing but what? The number of charges goes down from the what? Capacitor. So q naught maximum, it decreases to q. Next it decreases to what? 0 value. So as the amount of charges goes on decreases, this is called as the discharging of a capacitor in a what? RC circuit. In a RC circuit. Okay. So now this case we are going to study. So first I'll let you know what is the first basic thing when you will open the key. So when you will close the key, the battery starts to work. Are you agree? So whenever you will close the key, the battery starts to work, because closing of the circuit you will get, closed circuit you will get. But when you will open the key, no, the whatever the voltage is supplying by a battery is there, it will stop, because we will get a open circuit. It will be a open circuit. So not closed means it will not pass any amount of current. Okay, so that time what will be the voltage from the battery? This is the voltage. So when you will open the key, there will be no voltage from the battery, because it is an open circuit. So E is equal to what the value? E is equal to 0. Only when key is released or when key is open. So as soon as the key is released, when key is released, there will be no voltage from the battery. So E is equal to 0. So now this one I'll substitute in a what? The first equation. So when you will substitute in the first equation, what you will get? You will get this is equal to 0. So nothing but what? Q by C plus what is the I value? Here only I will write. I is nothing but the rate of flow of charges. So nothing but what? dq divided by what? dt into what is remaining? R will be remaining, which is equal to 0, because key is released. So E is equal to 0 value we are having. So that's what, when I'll substitute 0, the first equation becomes like this. That is Q divided by C plus dq by dt into R is equal to what? 0 we got. So now let's solve this equation. So on solving, what we will get? I'll keep this equation here and q by c term I will transfer. So what we will get? Yeah, we are getting dq divided by dt into r is equal to, as it is plus, when it will transfer it becomes what? Yeah, minus q divided by c value we got. Okay, so nothing but here I'll write this part. So dq divided by dt into r is equal to what? Minus q by c value we got. Okay, so just substituting the value of what? This I value and transferring this equation this side. Okay, and now q terms one side I'll make and other terms other side I'll make. Okay, so what are the q terms? One is dq and another one is this minus q. So when minus q will go here, so as it is in a numerator it will come to what? Denominator. Okay, so what we will get? Yeah, we are getting dq divided by q. Okay, now which is equal to, and what is remaining here? Minus 1 by c already there. And what we should transfer now? Yeah, r and dt value we should transfer this side. So transferring, as r is multiplying here, so when it will go, it will be divided by. So what we will get? Divided by r by c we will get is equal to minus 1 divided by r by c, r into c, into dt will be divided here. So when it will go, it will be what? Multiplied. Okay, so just a simple mathematical step I made here. So q terms one side I made and other terms other side I'll make. So what I got? dq by q is equal to r and dt. When you will transfer this side, it becomes minus 1 divided by r into c into what? dt value I got. Now we should solve the equation because we are calculating a discharging of a capacitor. So to calculate that, how much voltage will be dropped by the capacitor, that we should find. Okay, so that's what I'll do. What? Integrating the above equation. So when we will integrate the above equation, so what we might have got? Yeah, integration of dq divided by q, which is equal to integration of minus 1 divided by rc into what? dt. So just integrating. And as it is like dx by x, what is the integration of dx by x? Yeah, it is nothing but log x. So in the same way, dq by q, what will be the integration? Yeah, it is log q. So log q is equal to, and you know 1 by rc is a constant quantity. So I'll take outside minus 1 divided by rc. And what is remaining? Integration of dt. So what is the integration of dt? Yeah, it is nothing but what? T. Like integration of dx is x, integration of dt will be what? T. Plus something integration constant we should make. Okay. Now the question, what will be the k value? Because if you substitute the k value, no, then only we can find the what thing here. We can solve the thing. So that's what, to find the k value, I'll put t is equal to 0. Means when time is 0, nothing but what? Before releasing the key we can say. So when time is 0, how many number of charges are there in a capacitor? Yeah, maximum number of charges will be there. That is nothing but q naught. Okay. So when time is 0, what is this q value? Yeah, q value is q naught, because before releasing the key there are already many number of charges are stored in a what? Capacitor. So what we got? Q is equal to q naught we got. So t is equal to 0 means q is equal to q naught. So substituting in the above equation, so what we might have got? Yeah, we got log of, what is q value? Q value is q naught. So log of q naught is equal to, I'll write minus 1 divided by rc into, what is the t value? T value is 0 plus what it is? K. Means what the value we got? K, because this becomes 0. So k is equal to what we got? Yeah, we got k is equal to log of q naught. Log of q naught we got. So now again substituting. Now I'll call this one as the second equation. So substitute k value, whatever the k value is there, substitute k value in equation number 2. In equation number you substitute. So what we will get? Yeah, we are getting log of Q is equal to minus 1 by RC into T plus what is the K value? K value is log Q naught. So plus of log Q naught. We got the value. Okay. Now I'll transfer plus log Q naught to this side. So what I will get? I'll get log Q minus log of Q naught, which is equal to minus T divided by RC. This is the equation we got. Now as it is like log U minus log phi. So nothing but what? Log U divided by phi. So in the same way what we'll get? We will get log Q by Q naught. So log Q by Q naught is equal to minus T divided by RC. So as it is in the form of log U minus log phi, how we will write? Log U divided by phi form. So log of Q by Q naught is equal to minus T divided by RC. Okay. Now I'll write the same equation here. Log of Q by Q naught is equal to minus T divided by RC. And already you know, when the log we will transfer, no, it becomes e raised to we will get. Okay. So that time what the equation we got? So we got the equation Q by Q naught is equal to e raised to minus T divided by RC, because when you will log transfer, no, it become e raised to minus of this power, e raised to this power. So e raised to minus T by RC we got. So again transfer Q naught also. So what we will get? We will get Q is equal to Q naught into e raised to minus T divided by RC. So this is the equation we got. Now divide by C on both the sides. So if you divide by C on both the sides, what you will get? Q by C is equal to Q naught by C, which is equal to e raised to minus T divided by RC we got. Now as we know, Q by C is the nothing but what? The voltage across the capacitor. So in the same way, Q by C value becomes what? It is a phi, which is equal to phi Q naught by C means maximum charge. So nothing but maximum voltage. So that one we will write by phi naught. Understanding? So phi is the at a time t the voltage across a capacitor, that is Q divided by C. And phi naught is the maximum voltage, so which is nothing but what? Q naught divided by C. So phi naught into e raised to minus T by R into C. We got the equation. And in this equation we should substitute which value? Nothing but what? Time constant value. So what is the time constant? Time constant for a RC circuit is T is equal to R into C. The formula for the time constant of a RC circuit is what? R into C. So if I substitute here, what I might have got? I got phi is equal to phi naught into e raised to T value is what? R into C. So R into C already divided by R into C is there. So is it will get cancelled if you substitute T is equal to R into C here. So RC get cancelled. So what we got? We got e raised to what? Minus 1. Okay. So which is equal to phi is equal to phi naught into 1 divided by E. To make this positive, I'll take to the denominator. So 1 divided by E I got. So which is equal to phi naught divided by, and you know the E value. E value is how much? 2.72. So if you make that calculation, no, that is 1 divided by 2.72. So you are getting phi value is 0.368 on to phi naught. So this is what the voltage across a what? RC circuit. This is the voltage in a capacitor through the what? RC circuit. Okay. So as you compare the last equation and this equation, for the last side equation, for the last video equation, we got phi is equal to 0.362 into phi naught we got. But now what we got? We got phi is equal to 0.368 of phi naught. That is nothing but what? See, when you will close the key, the voltage starts to increase in a circuit. But when it will increase, no, it finally reaches to a what? Maximum value. So while reaching that maximum value, of 0.368 something 6 voltage battery you are supplying. So nothing but 6 voltage will be flowing across a circuit, but how it will not rapidly increases to 6 voltage. How it will be going like 0, 1 volt, 2 volt, 3 volt, like that it increases simultaneously. So while increasing that 0.368 into 6 volt, if you multiply something voltage you are getting, okay, so that is the voltage of what? Time constant, means that much time it will take. So time constant is nothing but what? The time during which 0.368 of maximum voltage reached by the circuit, means 0.368 into 6. Suppose example I am telling 0.36 into 8 into 6 voltage, if you multiply something value will get. So to reach that much voltage, how much time the RC circuit had taken, so that is called as what? The time constant. So time constant means what? The time during which 0.368 of maximum voltage discharged in a capacitor, we can say, because here now it is decreasing, isn't it? So from 6 to 36.8% to decrease the voltage, how much time the RC circuit is taken, that is called time constant. So I will draw the one diagram here, so if that you can completely understand. Okay, see, if I draw the graph of the voltage across the time of a RC circuit. RC circuit means two cases will come. One is a charging of a capacitor and another one is a discharging of a capacitor. What we are talking now. Okay. So while doing a charging, actually it is at a 0th voltage. But how time will be running? While doing a charging is nothing but what? You are closing the key. So voltage goes on increases and increases, and finally it reaches to what? Maximum value. This is a charging graph. At the same time, if you take on a discharging, so already the voltage will be maximum. So now you are releasing the key. So when you are opening the key, no, the voltage will be what? Decreases. So when it decreases, no, so it will come to what? Decreasing value, like this. Okay. So this is nothing but the charging we can say, and this is nothing but the discharging we will call. Means suddenly it will not come to 0 value like this. It will take certain time to go to what? 0 value. So like that discharging will be happening. And when you will multiply 0.368 of into V naught, so something value will get. Okay. So this is the time constant value. So that much time it will take to falls from this V naught to come this V value. Okay. This is the V naught value and this is the V value. So to decrease the voltage to this much, how much time it had taken, that is what the time constant. At the same time, if you take the voltage for a charging, no, here it will come. So this is what the time constant value, time constant, TC I'll write. Okay. So this much, how much time it had taken. So from this graph directly we can come to know. Okay. See, comparing the thing you read, then you can understand very easily. Otherwise, one point you cannot understand. See, in a transient circuit, two circuits are there. One is a RL circuit and another one is a RC circuit. In RL circuit, what? The resistor and inductor will be there. So there you studied the growth and decay of the current. Their current increases and current decreases. That time constant you calculated. But in RC circuit, what will happen? As we are having a capacitor, the function of a capacitor is to store the charges. So what will happen? As soon as you will close the key, the voltage goes on increases. So that voltage you will find there. As soon as you will release the key, no, the whatever the maximum voltage is there, it goes on decreases. So that decreasing voltage you calculated. Okay. So now while telling the discharging of a capacitor, we are having a resistor and a capacitor which are connected in what? Series. So both are connected in series with the battery, and starting the whatever the key is there, it is closed. So when it is closed, we know the voltage will be distributed among the two components. So E is equal to Q by C plus I into R value we got. where Q is the charge at a time t second, C be the capacity of a capacitor, I is the current, and R is the what? Resistance of a resistor. But when you will release the key, there is no function of the battery. That's what I wrote, E is equal to what? 0, because no any voltage is coming from the what? Battery. So E is equal to 0. So when E is equal to 0 means this equation becomes equal to 0. And now I'll separate the terms. So this term keep there, and the Q by C term transferring that side, it becomes a minus Q divided by C. Okay. Now this is the this equation something rearrangement we should make. How the rearrangement? Yeah, Q terms one side you make and other terms other side you are making. So making, you are getting the equation. Now integrating the above equation. So what we will get? We are getting this one, as you know the integrating rule. Now K value we should find. So while finding the K value, keep in mind when time is 0 means before releasing the key, there are a maximum number of charges will be there in a capacitor. So that's what Q is equal to, you got Q naught. Q naught value you got, okay. Because somebody will write when time is 0, Q is 0. Directly they will write, but it is wrong. When time is 0, maximum already electrons will be there in a capacitor, maximum number. So we should write Q is equal to what? Q naught. So substituting these values, we got K is equal to log Q naught. So substituting in equation number 2, you are getting the final equation. This is okay. So when you will transfer plus log Q naught to this side, what you are getting? Yeah, log Q minus log Q naught, which is in the form of log U minus log phi. So nothing but what you will get? Log U divided by phi you got, which is equal to minus T divided by RC. And as it is in for this form, transferring log to this side, it become e raised to V got. Again transfer Q naught also this side. So you got certain equation. For that equation, divide by C. So when you will divide by C, you are having this equation, because both side we divided by C just for a rearrangement. And as we know, charge divided by C is nothing but voltage. So phi is equal to phi naught into e raised to minus T divided by R into C you got, where V is the voltage at a time t second and phi naught is the maximum voltage. Means at a maximum time we can say. So this is the maximum voltage. Now in this equation, substitute the time constant value. See, for RL circuit and RC circuit, the time constant values are different. For RL circuit, the time constant is equal to what? You got R divided by L. But for a RC circuit, the time constant is equal to what? R into C. So that's what, when we will substitute here, we got phi is equal to phi naught into e raised to minus 1, because RC get cancelled there. And so as we know the E value, so 1 divided by 2.72 giving how much? 0.368, or you can call it as what? 36.8% of phi naught also. You can call like this one also, 36.8% of phi naught. Okay. So when the voltage is maximum, so let it be, if it is 100%, I'll tell. So when voltage is 100%, as it decreases 90%, 80% like that. So decreasing, it will reaches to 36.8% for some time. For one time it will reaches to this much voltage. So while decreasing, when it reaches to this much voltage, how much time it had taken, the RC circuit. Okay. So that is called as what? The time constant. So now that time we calculating. So for both the graph, charging and discharging, if you draw no, then what you will write? For charging, the voltage increases and next it will come to constant value. Same time discharging, the current decreases, then it will reaches to what? Approximately 0 value. So that's what, to decrease from V naught to phi. Phi value is how much? 0.368 of this V naught. So something value you got. So to decrease, how much time it had taken, that is the time constant. At the same time, to increase more for what? 0 to phi naught. Phi, what is the phi naught? Phi naught is nothing but what? The 0.632 of phi naught. V means 0.3632 of V naught. So if to increase that much voltage, how much time it had taken to increase, okay? So that is again the time constant. So for charging and discharging, if you draw the graph, no, you are getting at the same line you will come to know, okay? And one thing you should remember, for a charging or discharging of a capacitor, the time constant value is T is equal to R into C. Means, can we say the time constant is directly proportional to the resistance of a resistor as well as capacitance of a capacitor, okay? So as T is directly proportional to R and C, so time constant is directly proportional to the R. Means when resistance increases, time constant increases, and when capacitance increases, then also the time constant increases, okay? So as we increase the function of these two, no, so nothing but what, it will take more time to what, discharging, okay? So if both are less functions, means it will take less time to decrease. So that's what the thing. So this is what about the RC circuit, okay? So actually by seeing the video, you can write the what, this notes, because it is easy, only the derivation part is there. So whatever I thought, no, so you write the notes by seeing the video completely, okay? Thank you.